Okay, so we keep hearing about how AI is getting so advanced that it's starting to think, and now there's a whole new generation of models designed to do just that. They literally show you their work, their thought process, before spitting out an answer. It feels like a massive leap forward for sure, but it begs a huge question, maybe the question. Is this AI actually reasoning, or is it just getting incredibly good at faking it? Let's dig in and find out. So let's talk about what these things are. They're called large reasoning models, or LRMs for short. And no, these are not your everyday large language models. These guys are specifically built to try and copy how we humans solve problems, by creating these long, detailed chains of thought. The whole idea is that if they can think longer and harder, they should be able to crack tougher problems and be more accurate. And on paper, yeah, that sounds like a total game changer.
But is it real? That's the billion-dollar question, right? And it's exactly what a team of researchers, in this case from Apple, set out to answer. When one of these LLMs lays out its thinking, is it genuinely working through the logic step by step? Or has it just learned to produce text that looks an awful lot like a person reasoning their way through something?
Now, to get to the bottom of this, the researchers knew they couldn't use the old playbook. The standard tests we usually throw at AI, math problems, coding challenges, they have a really big flaw that can mess everything up. So they had to invent a whole new way to put these models to the test. Here's a good way to think about it. The usual AI tests are kind of like an open book exam, where the student might have already seen the answer key. It's a huge problem called data contamination. The AI could just be remembering stuff from its training data, not actually solving anything. So what was the researchers' solution? They used these controllable algorithmic puzzles. This is more like a clean, fair test of pure reasoning ability. They can tweak the difficulty with absolute precision, and most importantly, they can be sure the AI has never, ever seen that exact problem before. So what they did was build this sort of AI gymnasium, and they filled it with these classic logic puzzles that you might even recognize. We're talking about stuff like the Tower Hanoi, checkers jumping, river crossing puzzles, blocks world. The reason these are so perfect is that they're pure logic. You don't need to know any history or science. You just have to be able to follow the rules and plan your moves. It's the ultimate clean room environment to see how these AIs really hold up when the pressure's on. All right, so they run the tests, and what they find is, well, it's fascinating and definitely not what anyone expected. It turns out the link between thinking more and performing better isn't straightforward at all. In fact, their performance fell into three totally different patterns, or regimes, all depending on how hard the puzzle was. Okay, first up, the easy stuff, low complexity problems. And this is where we get our first surprise. On the simplest puzzles, the standard AI, the one that doesn't do all that extra thinking, was actually better. The more advanced reasoning model seems to overthink it. It gets tangled up in its own logic on problems that should be a piece of cake, kind of like it's trying too hard.
But then you crank up the difficulty a bit, into that medium complexity zone. And this is where those thinking models suddenly shine. This is their sweet spot. That extra processing, that chain of thought, gives them a huge advantage. They start solving problems that completely stump the standard models. So for a while there, it looks like the whole idea is working perfectly. And then you push them just a little bit harder. You get to the really complex puzzles. And everything falls apart. It's a total system failure. Both models, the one that thinks and the one that doesn't, just completely collapse. Their accuracy nosedives to zero. It's like they hit a brick wall, and beyond that point, it doesn't matter how much they try to think their way out of it, they just fail. So what in the world is going on here? Why do even these super advanced reasoning AIs hit this wall and just break? Well, the researchers wanted to know too. They decided to zoom in on this sudden failure, a phenomenon they started calling the reasoning collapse. Just look at this example from the Tower of Hanoi puzzle. As they add more disks, making it just a little bit harder each time, the accuracy is fine, it's holding steady, and then boom, it just falls off a cliff. We're not talking about a slow, graceful decline here. It goes from almost perfect to absolute zero, just like that. It's a catastrophic breakdown. Okay, but this is where the story gets really, really weird. I mean, your natural assumption, and mine too, would be that when a problem gets harder, the AI will try to think more, right? It would throw more energy at it, generate a longer chain of thought to try and crack it. Well, that is the exact opposite of what happened. This is just completely counterintuitive. As the puzzles got harder, the AI actually started to think less.
It reduced its effort using fewer processing tokens at the precise moment it needed to be thinking harder. It's almost as if the AI took one look at the hard problem, decided, nope, not for me, and just gave up before it even really started.
So, this just raises another huge question, right? What is actually going on inside the AI's head when this happens? To figure that out, the researchers basically performed a forensic analysis. They went through the AI's step by step reasoning to see exactly where things were going off the rails. And this is what they found. When the problems got really tough, the AI would often make a mistake very early on. But here's the crucial part. Instead of realizing it made a mistake and trying a different path, it would just fixate on that first wrong move. It would spend the rest of its energy, its entire thinking budget, just digging itself deeper into that hole, completely unable to self-correct.
So let's take a step back. When you add all of this up, the fact that it overthinks easy problems, that it completely collapses on hard ones, and that it can't even correct its own obvious mistakes, it really starts to paint a picture, doesn't it? It suggests that what looks like thinking might be nothing more than a very convincing illusion. But there was one final test, and this one, honestly, might be the real nail in the coffin. It was the most shocking finding of all, and it came when the researchers decided to make the test way, way easier for the AI. So get this, they didn't just ask it to solve the puzzle anymore. They literally gave it the recipe, the exact step-by-step algorithm for how to solve it. All the AI had to do was follow the instructions. And what happened? Its performance didn't improve one bit. It failed at the exact same point. Think about that. It couldn't even follow a perfect set of directions. And this led the researchers to a pretty stark conclusion, and I'm quoting here. These models failed to use explicit algorithms and reason inconsistently. In other words, they can't reliably follow a logical plan, which, when you think about it, is the absolute bedrock of what we consider to be reasoning. And that brings us right back to where we started, but the question feels a lot heavier now, doesn't it? If an AI can't even follow a recipe that's handed to it on a silver platter, can we really say that it's thinking? Or is it something else entirely? A master mimic, an incredible impersonator, creating an illusion of thought that's powerful, convincing, but ultimately completely hollow?